Hello, friends. Welcome to Clarify and Decode, where our aim is to demystify software engineering. We aim to provide clear, conceptual, lifelong learnings, removing all the jargons. So, today we would be checking on how to debug a live performance issue. It's part of our series on software performance concepts. It's the first part, and I have made it as a stepping stone for people who want to venture in this area. So, it's very good for developers. I have kept it from developers' perspective because I would be explaining it in terms of the inbuilt capabilities of IDE on how to check the performance issues. So, let's get started. So, I've made an API which replicates a performance issue. I would explain it on the high level. So there is a simple get endpoint which does a looping. A large number of loops are done, and then there is a method for high memory allocations. So it will cause the performance issues. And we will see how we would like to get back to the root cause from this. So let's get started. Okay, so performance issue, let me fire this and I execute it. So I'm using Visual Studio, which has a very good diagnostic tools, but I will relate it with all languages and not tool specific. Basically, what do we do? Okay, we know there may be memory spikes, CPU spikes, but what to do after that? Fine, I will explain in further detail. Okay, so let's say the loop is going on, and here we have the counter, so it keeps increasing, and I have some method to generate random names, and purposefully it's not written very well. It has a lot of things which can be optimized, but will focus from the aspect of the tool. So let's continue to do this. Fine, as it's the first video, I would focus mostly on memory allocations and CPU spikes, because all other things which are higher constructs like maybe deadlocks, thread contention, anything else would also relate to this. So I've tried to start with the very basic, and in the next videos we would see other points on this. So here we would see the CPU is spiking a bit. So try to let it run. Okay, it's loading. Okay, there's a performance issue that is intentional many ways in production and in our enterprise development. It would be non-intentional, and still we need to find it. So here you see, in every tool we would have a starting point, like when the process started, when the actual requests came after it. So it's 1 milliseconds, and okay, it's starting and it's running. So what we can do, okay, I have tried to get further details by having a break. Okay, so you would see in this context the CPU is getting higher. Okay, and the memory after a point also was very high. Okay, so this is the point where our methods, okay, the get names would have fired, and it would have created the spike. But there's one interesting thing. The memory is not going above 150 if you see carefully. It should have, but here what is happening, garbage collection is kicking up. You see this yellow point indicates garbage collection. Okay, so it's very frequent garbage collection is happening. That means whatever memory is getting taken by the objects, garbage collection is trying its best to deallocate whichever it doesn't find references or by its algorithm. Okay, fine, we'll go into further details. So let's see what do we have from here. Let it run a bit. Fine. If we try to see what's happening, it's still loading because there were a lot of loops and it's trying to fetch all the details. But see, something interesting has come up. First, I would be going from perspective of CPU, then I would be focusing on process memory. See, here if we say 100% CPU breakdown, we see a large percentage of it's being said is being used by string concatenation. Okay, and we have our culprit as well. So this is the performance controller and the generate name method. Okay, so in actual case there would be a lot of controllers, lot of services, lot of methods, but still you'll have to see what is consuming or taking the highest amount of CPU. So for CPU context, we try to see what is eating most of the CPU in terms of like a method you have written, internal system level methods. Okay, fine. I would come to this point as well for the insights, but this is very well we are getting it. But let's see the magic from here on. Okay, so I'll just click here. Okay, now we are in a view for functions. We know the process ID is starting with IAS, and we had the performance controller. It's taking 44%. This is the system internal derivative. Usually we try to relate, but first we try to find business level functions because those things would be internally utilizing system derivatives, framework level methods. Fine. Just a minute. Okay. So now what I was saying is it's actually giving me and pinpointing the method which is causing the issue. Okay, even after this it is saying within this method string dot concatenation is the major culprit. Okay, because here you see there are concatenations done which are not very optimized way or not the best way. Okay, so this is one clear picture you should have. Okay, which method you should focus on first whenever you are having a performance issues. You cannot focus on all. Maybe you can distribute, but you first need to identify which methods you would improve. Sorry. Now let's see something else, because in each IDE, each language, this is the same concept for performance improvement. there is something called flame graph. Okay, the flame graph, what it is saying is, if we say this is the overall thing that is taking up our resources, then it tries to prepare something like a graph. It's not very fine tuned because this is just an example, but we have very, very big flame graphs. We will know the hot areas for that. So here, the hot area is still this, and here we will come to this. So I'll try to be quick because I think you get the idea. So we can also have the construct in terms of who is calling. Sorry. So here, this is the flow, and if you see everything, each visualization is pointing to the same thing, generate name. Okay, so let's see what are this. Call tree is similar, functions we have already seen, and fine. I think you understand what needs to be checked for CPU. And there is one more important thing with recent developments. We have a lot of insights. See, it is saying don't use string concatenation. Rather, we should use string text builder, because here, normal string concatenation, we are spinning a lot of objects, okay, each time. And with string builders on the same object, we can make the changes. So it's more performant. Okay, because we are not taking a lot of memory and other derivatives from it. We even have copilot also, but you get the idea. We can visualize, we can also get some insights. Fine, let's see where our code has reached. Okay, let it be. Now if we see, process is like 154. Let me do one other thing. I will try to put, I think it has already executed till high memory allocations. I wanted to see from here, but let's see what's the result. Anyways, let's see what do we have in the performance front. Or maybe let me restart it once again. So what is the counter? 16,607. Okay, fine. I have put a lot. But anyways, this you understood. It's causing CPU spike. I have purposefully put something directly for high memory allocations. Okay. So let's go here. I set up as next statement, and let's go here. Okay, fine. A lot of bytes I've tried to spin up. Fine. Okay, fine. It has fired the block. Now let's see if something interesting happened here. So let me take a snapshot. And let it spin up some data from its side. Fine. We have a snapshot. Okay. So let's see what happened here. I will also show the dead objects. Okay, we saw that we had spin up some bytes, right? You see how much it is. Okay, you will get this, like which all objects are taking the most space, or already if they were dereferenced, but still we will get detail from it. Let's say for an example, byte, what we can do from it, because if it's just byte we will not understand, because byte can be used in almost like all the classes, numerous points, but which bytes, which particular piece of line of code is causing this issue. So we have something called find all references, and see we come to the point through which we can link, okay, these number of bytes, and we see lot of allocations here, and then we try to relate and fine tune. Okay, instances, it would be the individual instances, but fine. Okay, so we also have string, right, whose count is very high. Think it would be the same string points we had purposefully done wrong. So let's see where does it points. Yep, to our methods, like the check get name points. So fine, I think you get the idea, like we can get the heap size, and then we can filter based on the size, based on the count, and then we can try to find the references directly in the code, tell the method, tell the code line, and we can try to fine tune from that. We even have, as I said, insights also. So it will say, okay, many times we have used sparse arrays, which can be improved. Many times we have duplicate strings. So it's all giving you the picture how to improve on that. Okay, fine. I wanted to show you the spike, but let's see if it's coming or not as of now. Let's continue. Okay, fine. I could not pinpoint in this long duration, but what I wanted to show you, like whenever we were firing this a high memory allocation, there would be a spike in the process memory. So when we would be debugging, we would have a lot of time, right? Like, and here we need to identify on this dashboard load and this button click in this API call, the process memory shoot it. And we have to just go to that time frame. We don't need to have the picture of the time the process was running. So what we'll do something like this. Every tool will have this. So suppose we said in this time frame we saw the speak CPU spike. Maybe we spun up something, a background thread, or a lot of computational task from one method. Then we have to fine tune to that time, maybe a minute, 2 minutes, whatever suits, and then do the same operations of finding the culprit from there. Because if we take a very long time, it would be very difficult. We'll have a lot of data from different methods, right? It will give the overall picture. We need to be judicious as well, just to take a small time frame, okay, when the issue is happening. Okay, fine. I think I have covered pretty much in terms of the first step. Whenever we are having a performance issue, we are in a local development setup, please try to see the CPU metrics, please try to see the process metrics. Other things are also there, like if there are a lot of calls, okay, and we see, okay, the total request counts was 10, but somehow for some duration it was like 1000. So there was a lot of traffic which caused the spike. So the counters can also relate. But if we say the counters remain same over a period of time and still the issue happened, maybe the counters would not help much. We also have events like what we did in terms of like I would say the operations that we did, getting the insights and other points. Okay, like a summary here. We took the snapshot, we recorded the CPU profile. Okay, fine. I think it's fine for today. Later sessions, I would try to have higher detailed issues like what if there is a thread lock. See, we'll have multiple threads running, right? One of the threads is causing the issue. Then how to identify which thread was causing the issue, which method, which behavior, how to fix from that. Okay. And performance issues, generally it's like I would say 10, 15, 20 most common points we have to check, and majority of the cases will come to the reasons. Fine. Please excuse me. Okay. Let's finish this session, guys. Today, my voice was not very good. I have a little throat infection, so I didn't raise my voice much, but I hope the recordings are clear. If not, please, I beg your pardon. Please just put focus and try to listen once again, and you will get the gist of what I am trying to do. And I will be back for the second part of this session. My aim is like software performance is very, very easy to crack, but we are so much worried about development, and many people don't get chance to like delve into this space. But this is very, very necessary to understand how things are going about. This is just the IDE. In real case scenarios, we have even more tools, external tools for Java, JProfiler, for .NET. We have a lot of things with JetBrains, .trace, .memories. Above and top of that, we have application performance monitoring tool. So there, what will happen? Everything would be running in production. So suppose this performance API was running. There we cannot just do a local debug, right? We'll have to set up and see. So what they do is they will give us live CPU profiling of each and every process that is being monitored. So we will get those details just in the dashboard of Dynatrace or Datadog, and it's very, very easy and at one place to understand. But the concept remains same. If it is CPU spike, try to find the hotspot. Which method is taking most of the CPU? It may be a computational method or maybe other factors. Process is high, try to relate which objects are taking a lot of space. Is garbage collection happening properly or not? Okay, are there some survivor objects? Those kinds of concepts. Fine team. So let's connect again. Hopefully I will come back very soon. Stay tuned, stay learning, and I try my best to clarify the concepts. Thank you.